So now instead of just solving for x and y, we're throwing a z in there, and we're going to solve for all three of them. So instead of getting an ordered pair for an answer, your answers will look like x, comma, y, comma, z. Like you're going to have three answers. So when you have two variables, you only need two equations to solve. But when you have three variables, you need three equations to solve. Otherwise, it's not possible. And so with every added variable, you need another equation to either substitute or eliminate to get an answer. And so when we start doing word problems with three variables, we'll actually be creating three equations instead of two. Fun fact. So I have all of these steps written out for you, and I realize that sometimes it's hard to like read all of those steps and understand what to do, but they're there just in case you need to go back and help. But we are going to do some examples that hopefully cover how to do them. So in my opinion, I think that solving linear systems in three equations, you have to do elimination and substitution at the same time. But there's some that it's easier to look at it and say, I'm going to start with elimination. Then there's some that it's easier to look at and say, I'm going to start with substitution. So we're going to start with this elimination. And basically, the way elimination works is you're eliminating one variable twice to get it into a 2x2 and then solving it that way. So you're going to isolate two problems or two equations and eliminate a variable. Then you're going to do the same step again. So in this one, I'm going to try to use as many colors as possible to help you guys understand. But if I look at the last two equations here and here, what is a variable that I can go ahead and eliminate? Z. I can already go ahead and eliminate z. So then I'm going to combine, and it's going to become 4x and then plus 2y equals negative 2. Okay, then I'm going to take two other equations and I'm going to eliminate z. So I'm going to pick two different ones. And so what other two equations do you guys want to do to eliminate? Bottom and top. Perfect. Bottom and top. So I'm going to eliminate the z for those. No multiplication involved, which is kind of nice. And then I will combine. So I'm going to write it underneath. So 2x minus x just gives me x. Y plus 3y is plus 4y. And then a negative 3, positive 6 gives me a positive 3. So now I have a 2x2, two equations, two variables. And now I'm going to use the knowledge that I have from prior sections, 3.2, and I'm going to solve it. So I'm going to, do y'all want to do substitution or elimination on this? I like elimination, so let's do that. Let's multiply. What do y'all think we should do to eliminate? Okay. Yeah, I could multiply the top one by negative 2. So that gives me negative 8x minus 4y equals a positive 4. The y's will cancel. Negative 7x equals 7. And so x equals what? Negative 1. Now, once you get the first one, it's so easy because you just go and you plug it in and you plug it in again. It's like, now this is where substitution kind of comes in. So I take this x equals negative 1 and I plug it into one of these two. I'm going to just plug it into the top one. So then I get 4 times negative 1 plus 2y equals negative 2. And I solve for y. So then y equals what? 1. let you guys catch up for a second. So once you have your x and your y, you're going to substitute both of those. So I'm going to take this x equals 1 and this y equals 1, and I'm going to plug them both into one of the first equations to solve for z. I usually just choose the top one, but you can choose whichever one you want. So 2 times negative 1 plus 1 minus z equals negative 3. You should get z equals 2. So my final answer would be, using the ordered pair, or I guess the ordered numbers because there's 3 of them, make sure that you write it as x, y, z. So negative 1, comma 1, comma 2. Okay, so with this problem, my suggestion is to first decide which variable are you going to eliminate. I look at the ones that have like multiples of each other so that I don't have to multiply all of the equations. So in my personal opinion, it is easiest to choose the z's in this exact problem because I have one that has a z with a coefficient of 1, so that means I can just multiply it to be 2, and I can multiply it to be 3. Like I can multiply it twice, okay? So let's look at, I'm going to do the top 2 first. And I need to multiply the second equation by 3 in order to get the z's to cancel. So I'm going to rewrite them. So I'm rewriting the top one to stay organized because I have so much space. And then I'm going to rewrite the second problem by multiplying it times 3. So 3 times 2, 6x minus 9y plus 3z equals negative 48. Then I add down, so 11x minus 11y equals negative 55. Are we good with that so far? I did the first 2, yeah. Now I'm going to do the second 2. And now I need to multiply the middle equation by 2 in order to get the 2's to cancel, the z's to cancel. So when I multiply the top one by 2, it becomes 4x minus 6y plus 2z equals negative 32. And then I'm going to rewrite the bottom one, but I don't need to multiply it by anything. Those will cancel. I add down, and I get 7x. I'm just coming up over here. I add down, so 7x minus 2y equals negative 25. Then I'm going to rewrite this problem over here. And so now I have 2 variables. And I'm going to solve either using elimination or substitution. That shouldn't be 111. I don't know why that happened. It looks different on my screen. Very strange. In this case, I think in this case it's easier to do substitution to solve. And let me show you why. If I solve for x in this equation, I'm going to get a nice little number because everything divides by 11 evenly. But you can do elimination if you want, and you're going to end up getting the same thing. It would just mean that you have to multiply the top and the bottom to get it to cancel out. But if I solve this for x, I end up getting 11x equals 11y minus 55. Divide by 11, and I get x equals y minus 5. Isn't that kind of nice? Yeah. And so then I'm going to substitute that in right here in this top equation. So 7y minus 5 minus 2y equals negative 25. Are you guys following me so far? This is why you feel smart, because then in the end you get numbers and it all works out. It's just like a whole page of work. So then distribute 7y minus 35 minus 2y equals negative 25. Combine like terms. Add the 35. So 5y equals 10. Y equals 2. And from here, it's like smooth sailing after this. So once you get that one variable number, you can just plug it in, and then it gets easier. So if y equals 2, I'm going to plug that into the equation that I substituted. So if y equals 2, then x equals 2 minus 5, which is negative 3. And then I need to go up to the top, and I've got x and y, and I need z, so I'm just going to choose one of them to plug it into. Let's do the top one. 5 times negative 3 minus 2 times 2 minus 3z equals negative 7. I probably should have chosen a different one to plug into. This one's kind of a lot. Negative 3z equals 12, so z equals negative 4. Oh man, so much. Okay, so my ordered pair, x is first, so that's negative 3. Then my y, which is 2, my z, which is negative 4. Okay, with substitution, it's a little different. So with elimination, you tried to eliminate one variable twice. With substitution, you're trying to solve for one variable, and then you substitute that variable twice. Okay, so you have to do everything twice because there's 3 equations. And your whole goal is to try to get it to a 2 by 2 so that then you can solve using the methods that we already learned. So with substitution, this one already gives us 1. It gives us z equals 4, which is very handy because I can take that and then plug it into this middle equation. So y plus 3 times 4 equals 10. So y equals what? Negative 12 or negative 2. So I've got z equals 4, y equals negative 2, and I take those and I plug them both into the top equation. So 2x minus 3 times negative 2 minus 4 equals 12. Two x equals 10, so x equals 5. So my final answer as the 3 ordered numbers would be 5, comma, negative 2, comma, what's z? 4. Okay, looking at this one, which equation, top, middle, or bottom, would be the easiest to solve for one variable? Middle. The middle, and then what do you guys want to solve for, y or z? You could do both, but we're going to just choose one of them. Okay, let's do y. So I'm going to take this and solve for y. So y equals 5 minus z, or z, negative z plus 5, either one. And so now I'm going to choose one of them to plug into in order to solve for my other variable. So I could take this equation and I could plug it into the bottom one for y. And then I'm only left with z's. Okay, and then I can solve for z. Z is a number. So 2 times 5 minus z minus 4z equals negative 14. No fractions. Yes, I got 4. So then if z equals 4, what can I do now? Y equals 1. How'd you get that? Yes, so 5 minus 4 equals 1. So I've got 4 and I've got 1. I'm going to plug them both into the top equation. So x plus 1 plus 4 equals 7. So you should get 2, 1, 4.